This is Activity 1, Matching Hangers from Lesson 3, Balanced Moves. And so now in this activity, what we're going to do is start moving these shapes around and removing some shapes and keeping the hangers balanced. And so there are 4 different hangers, and there are 4 equations, and we're supposed to match the equations with the hangers. And I'm going to start at the end. Back here, I'm going to start over here and work backwards. So I'm going to add things to this hanger and eventually get to hanger A. And so right away when we start, we can see that 1 square is equal to 2 triangles. And in the equations, that's going to be this equation right here. This is the simplest equation, and you see that 1x is equal to 2y's. And so we're going to see that the square is equal to x, the triangles are equal to y, and that means the circles over here are going to equal z. So the squares are x, the triangles are y, and the circles are z down here. But don't worry about that right now. We will come back to that. So first triangle, 1 square is equal to 2 triangles. So 1 square, so you can remove the 1 here, and it's understood that that's 1 square. So 1 square is equal to 2 triangles. And now if we go backwards to hanger C, we have to find this 1 square and 2 triangles and then look at what's left over to write that equation. So there's the 1 square, 2 triangles. We know that's equal to each other, so we can remove this square here, and we can remove this triangle here, and we're over to D. So if we work backwards now, so what is the equation? For this left side, you have 3 triangles and 1 square, and that's equal to 2 squares and 1 triangle. So now we're back to here, and this is the equation that goes with this hanger. All right, so work backwards from C to B, and so we know this is the equation for C. Now we need to find this hanger over here, and if you look closely enough, you can see that there are 2 of them. So here's this, the left side of this hanger, and here are 2 of those. So we can write that as 2 of these groups. 3 triangles plus 1 square, so 2 of them. And that's equal to, and you have to be able to find 2 of these. So if this is 2, so we've doubled this side. So we also, at the same time, we have to double this side. So we have to be able to find 2 of these. So 2 squares and 1 triangle 2 times. So 2 squares and 1 triangle 2 times. And so that's right here. Here's 2 squares and 1 triangle. That's 1 time. And here's 2 squares and another triangle. That is 2 times. So now what we can do is look at this side as 2 triangles. So this is 2 times these groups. And now we're going to use the distributive property and rewrite this as 2 triangles. There's 2 triangles and 4 squares. 2 times 2 squares is equal to 4 squares. So 2 triangles plus 4 squares. And this is the next equation working backwards. This is the equation for B. All right, so now we have 2 groups of 3 triangles plus a square, and we have 2 triangles plus 4 squares. And now to get back to here, do we see this somewhere, these 2 groups of 3 triangles plus a square? And yes, we do. So this is right here, and this is right here. So this left side we can write as 2 times 3 triangles plus 1 square. 2 times 3 triangles plus 1 square. It's the same as this right here. And we should be able to also see this right here, which we do. This is 2 triangles plus 4 squares. Here's the 2 triangles plus the 4 squares. And to both of these, what's added the same amount on each side are 2 circles. So 2 groups of 3 triangles plus 1 square plus 2 circles. And on this side, it's 2 triangles plus 4 squares plus 2 circles. So now we're going to match these equations. And so here's the equations all written out. And interestingly, if you have 2 triangles plus 4 squares, So 2 triangles plus 4 squares, and I have 2 of those. So that's 2 groups of a triangle plus 2 squares. That's equal to 2 of these groups. So now if I remove one of these, 3 triangles plus a square, so I have 2 triangles plus 4 squares, and I remove one of these from this side, then to keep it balanced, I should be able to remove the same amount from this side, so subtracting that 3 triangles plus 1 square. So I'm going to go through a little bit of algebra, and this is the idea, to get used to moving these symbols around. When do they change signs? When can you multiply, divide, add, subtract, and keep everything balanced? I'm just going to go through this. Is not part of the activity. I'm just going to go through this and show you that I'm going to look at one of these. In the end, that means that I have to look at one of these. So if I subtract one of these from this side, I should get this triangle plus 2 squares. I'm too much explaining, so let's just go through it. So now I have 2 triangles plus 4 squares plus, now it's going to be the opposite of this. This is one of the hardest things in algebra, to make sure you don't make a mistake. So I would change this to addition, and you're going to multiply by the multiplicative inverse. So the multiplicative inverse of a positive 1 is negative 1. So you're going to, actually you're going to add with the additive inverse. So instead of subtracting a positive 1 times all of this, you're going to add the additive inverse, which is a negative 1. So it's easy to get confused. And so what's the opposite of 3t plus s? It is a negative 3ts. So a negative times a positive is going to give you a negative value or negative amount. So it's a negative 3 times the triangles plus a negative 1 times that one triangle. So negative 1, I'm sorry, square. A negative 1 times the square. So now we combine all the symbols that are the same. So I have 2 t's and I have a negative 3 t's. That gives me a negative 1 triangle. And I have 4 squares and a negative 1 square. So that gives me 3 squares. All right, so where do you go from here? Because we're getting close. We have to get to a triangle plus 2 squares. And right now we have a negative triangle plus 3 squares. Now remember that a square is equal to 2 triangles. I'm sorry, this is getting to be a little bit long, but anyway, a square is equal to 2 triangles. So I can separate this out into 2 squares plus 1 square. And that 1 square is equal to 2 triangles. That's right here. 1 square is equal to 2 triangles. And so now I have a negative 1 triangle plus 2 squares plus 2 triangles. Well, 2 triangles plus a negative 1 triangle gives you 1 triangle. And so we're there. So a triangle plus 2 squares. That was a bit much. I would practice going through it, thinking about it, and just listen to the video and see if each of these steps makes sense, and try to talk through it. All right, and this is where I got the 1 square is equal to 2 triangles right here. This 1 square is equal to those 2 triangles. All right, so let's match the equations. So these are the equations that are given to you. And from this equation, we have triangles and squares and circles. So what's x, what's y, and what's z? And you can see that this is 2 times 3 triangles, so this is 2 times 3y. That means the triangles are the y variable, the squares are the x variable, and the circles are c, the z variable. All right. So squares are x, triangles are y, and circles are z. So now to go to the next step. So now what we're going to do is work our way down from A to D and solve the equation, get down to what's the value of x. So to get to B, what we're going to do is add a negative 2z to each side. So to get rid of this 2z And to get rid of this 2z, we add a negative 2z to each side. And that leaves us with 2 times x plus 3y, and that's equal to 4x plus 2y. And that is right here. That's B. And then to go from B to C, what we're going to do is on the left side, we're going to multiply the left side by 1/2. So it's the multiplicative inverse to remove this 2 and to make this equal to 1. And you have to remember to multiply both terms, not just one term, but both terms by that same 1/2. So it's 1/2 of 4 is 2, and 1/2 of 2 is 1. So now we're left with x plus 3y, so it's just one of these, is equal to 2x, so 1/2 of 4, plus y, 1/2 of 2. And to get to the last equation, we're going to subtract or add a negative x to get rid of this x. So 2x plus a negative x is 1x. And we're going to add a negative y to get rid of this y. And 3y plus a negative 1y is 2y. So we added a negative y to both sides. Negative y gets rid of this one, and this goes to 2y, and added a negative x to both sides. Negative x gets rid of this x, and 2x plus a negative 1x gives you this single x. So you're left with x equals 2y. Little bit much here, sorry about that. And this takes a lot, so just go through the video and see if you understand each step.